Hello, welcome everyone to this very nice introduction, and thank you, Quincy. Oh boy, I think one day if I need someone to sell myself, I will definitely hire Quincy. So let me know if everything's right, if you can hear me. My name is Florin Pop. I'm a developer from Romania. I've been coding for 7 years, and in November I started a YouTube channel. You can subscribe there if you want to follow me. We have almost daily live streams and different tutorials. And also, if you want, feel free to follow me on Twitter, where I'm posting almost daily. Yeah, let's start working on this new crazy challenge. Quincy has been asking me to start this because, it's an interesting challenge. And we're going to do it on the freeCodeCamp website, and we're going to do it with JavaScript, which is pretty nice. Hello, Eduardo. Feel free to join the chat. This won't be that kind of, tutorial where I'm teaching you and it's all formal. It's just us hanging out, sort of, and solving coding challenges with JavaScript. This is what I'm doing on my channel also. So I haven't prepared for these challenges because I wanted you to see the progress. So I wanted you to see that it's okay to fail. It's okay to Google sometimes things. It's okay to not have the perfect solution. It's all part of a developer journey. Keep in mind that I've been programming for 7 years. I've been working as a freelancer. I had a job, then freelancer again, then another job, and then I turned into content creator. This is what I really like to do. So yeah, thank you freeCodeCamp for giving me this huge opportunity. I usually stream for 40-50 people. There are 1,000 and so people now watching, which is crazy. I was pretty nervous, but now I'm fine. Yeah, so say hi in the chat if you're watching, if you can. Also, it's don't tell anyone, but in my opinion, you should support the freeCodeCamp channel. They're doing an amazing thing, so feel free to become a member, and then you will be able to join the chat. If you have questions at any time, feel free to ask them. Also, I might need your help sometimes, so feel free to help me. Hello TM, Sunny, Eric, hi all of you. Okay. So yeah, let's see Hey Kaja, how are you today? So this is the Project Euler set of problems, coding challenges. This will be the first series. And then I will be doing, I think, weekly live streams in which we're going over these problems. There are hundreds of problems, but this challenge is the first 100. Now, I'm not sure if we can go over all of them that fast because they're getting harder and harder, but we're going to try. All right, so yeah, Project Euler is a series of challenging mathematical and computer programming problems meant to delve into unfamiliar areas. Oh, by the way, if my English is off, that's because I'm not a native English speaker. So yeah, anytime you don't understand what I'm rambling around, feel free to stop me. And as I said, I usually am on my channel. We're all here as a family. We're learning together. We're having fun. I don't have my orange lemonade now. Usually we have an orange lemonade, and we're having fun. Okay, so I was thinking that in this stream we should do the first 4 or 5 problems to see how it goes. As I said, I haven't really looked into it, just the titles, but we should be fine, hopefully. Hello, Travis. How it's going? Awesome. So yeah, the first problem, multiplies of 3 and 5. If we list all the natural numbers below 10 that are multiplies of 3 or 5, we get 3, 5, 6, and 9. Alright, the sum of these multiplies is 23. Okay, so we need to add up the sum of the multiplies of 3 or 5. Alright, find the sum of all the multiplies of 3 or 5 below the provided parameter value number. Okay, so apparently we have a function which gets in a number, and we need to return the sum of the multiplies. Alright, so let's see. First, we should probably loop over all the numbers from 1 up to, well, the number provided. And we should check if that number, so all the numbers in the loop, if they are multiplies of 3 or 5. So if they, their modulus, I guess, the division by 3 doesn't have any reminders. Hopefully I said that right? Okay. So, hey Adam. Yeah, thank you. Good. So let's see. We want to create a loop. Let me know if the font size is big enough, if you can see the code. I don't know if my face is in the way, or yeah, I should probably remove these social buttons or whatever they are. And yeah, if anything's not okay, just let me know and we can fix it. All right, so we're going to do a for loop starting with 1. Well, I guess, yeah, we should start with 1 because we could have a number less than 3, right? So we should start with 1. And then we want to go up to the number, right? So I less equals than the number, I plus plus. Okay. And so first I'm going to do like a brute force thing, so not very optimized, and then we can try to improve it if, I don't know, if we find a better way to do it. Hello, Marco. So yeah, thank you, by the way, thank you to all the poppers. The poppers are those who've been following me. Yeah, the poppers family. Thank you all of you for being part of this. You've been very supportive. I was very nervous at the beginning. And yeah, I highly appreciate you being here. Also Marco, seems that he became a member to be in the chat. So yeah, very nice of you. All right. So we're looping over all these numbers. Now we need to see if they are multiplies of 3 or 5. I guess I don't need this anymore. All right, so let's check here. If I, right? So if I modulus 3 is 0, or, oops, that's, yeah, you'll hear a lot of oops, you'll hear a lot of goodies, you'll hear a lot of things. I just hope you enjoy it, and the most important thing, I really hope that you're learning something. Yeah, what we should be looking for is to become every day, to become just, I don't know, if we can become 1% better than we were yesterday, that's already a huge. So yeah, good. So 1 modulus 5 equals 0. I always mix up, is this the modulus operator, or yeah, someone correct me if I'm wrong. I might be wrong multiple times, so that's fine. Okay, so if that's the case, then we want to add this I to a sum, right? So let's create a sum with let, not with const. Let sum first will be equal to 0. And here we can say sum plus equals I, right? And so they will add up. Let's make some space here to have a pretty code. And at the end, we should return sum, right? If my logic is correct, hopefully it is, this should be good. So let's see. All right, something is off. What did I do wrong? So if it's 3 or 5, then we should add I. Okay, up to 1000. That should be, Does anyone notice anything? Where could be the issue? All right, let's console.log and see what we get. So for 1000, we should get 233,168, and we get, oh, okay, I think I know where the problem is. So you can see the difference between this and the value we should get. It's like 1000, and 1000 is the number we're looking. So yeah, it says here below the provided parameter value. So that's the issue. We went up to including the number. So we just need to remove here the equals. And now you can see that we are getting the correct answer. And let's run this and look at that. Pretty nice. We solved the first one. Awesome. All right. Let's think. Yeah, I less than number. Thank you, Kaja. Yeah, also keep in mind that there might be a delay from the time you're seeing this. Well, to the time you're commenting in the chat and I'm seeing that. So yeah, keep that in mind. All right. Could we improve this, or should we think about improving something like this? I always try to think maybe we could have some kind of array method or something fancy, but yeah, it doesn't seem like we should even think about something. It's pretty clear. We have a sum which is 0, then we loop over all the numbers, and if they are multiplies of 3 or 5, then we add the sum. So I guess this should be a pretty good solution. If you have any idea of how can we prove this, maybe I don't see it, or who knows, let me know. But for now, let's submit this and go to the next challenge. All right, good. The second one, even Fibonacci numbers. Now let's see what this requires. Each new term in a Fibonacci sequence is generated by adding the previous two terms, by starting with 1 and 2. So yeah, we have 1 and 2. The next one will be 1 plus 2, for those of you who don't know about the Fibonacci sequence. Then we have 2 plus 3 equals 5. Then we have 3 plus 5 equals 8. And then we have so on and so forth. All right. By considering the terms in the Fibonacci sequence whose values do not exceed n, so again, we don't need to go over n, find the sum of the even valued terms. All right, so let's take some notes. We need to not exceed n. What I'm writing here. Okay, so up to n. Then we need the even numbers. All right, and we need the numbers will be in a Fibonacci sequence, right? Okay, look at this motivating message. You can do it. All right, we can do it. Okay, so I guess we should start by having the Fibonacci numbers, the first two Fibonacci numbers, right? Okay, so the Fibonacci value should not exceed. All right, so let's do the following. Let A be the first one, or I guess we could call it A be the first, be 1, and let B be 2. Okay, so these are the first two Fibonacci numbers. And now we want to go to keep adding these and changing these variables. This is why I used let until we are up to the n. So again, now because we don't know exactly, last time we used the for loop because we knew exactly how many steps we have. But this time we don't know exactly the number of steps, so we're going to use a while loop. So then we're going to use while, and we need a condition here. Which will be the condition? So in the next loop, B will equal, A will equal B, so A will be 2, and B will equal A plus B, right? So it will be the next number. So we need to check while B less than n, right? So this is our not exceeding n. Okay, and we also need to keep in mind that we need the even numbers. All right, and we need a sum. So let's create that variable. Sum will be, let's think. We want the sum to be 0, or we want the sum to be A plus B by default. I guess will be A plus B. Oh, but no, because A will be an odd number. So we only want the even number, so that's B, right? Should we have B less than n as Kaja? No, because we want to go up to and not Oh! Yeah, see? Yeah, you're right. So it not exceeding means that it doesn't go over. So it could be up to and including. Very good, thanks. Yeah, so not exceeded, but included. Okay, good catch. See, we might sometimes just mess it up, but it's fine. And this is why I like the live streams. Well, on one hand, I just I don't know, get the fool of myself. But on the other hand, I have my helpers here, which will make sure that whenever I fail, it will still run. Okay. Yeah, and we'd also figure it out when the code fails. So probably this is a bit overthinking on my side, just to, I don't know, lay out the building structures, I guess. Oh well. Okay, so here we want to get the new value, so the new Fibonacci number, which I said that A will be B and B will be A plus B. But here is an issue, because now we modified A here. So we need a temporary value in which we're going to store A. Then we're going to change A to be B, so it will be the next element in the Fibonacci sequence. And then here, instead of storing into A, we're going to do temporary plus B. All right, and now if B is even, so meaning that the division by 2, the remainder should be 0, right? So if it's even, we want to add it to the sum. So sum plus equals B. Now, if my logic is correct and I didn't screw it up again, we should return sum. And let's run to see. Oh, look at that. So this time we did it correctly. Yeah, let me know if you understood this. Let me know if you have any questions. I'm going to wait after I finish one challenge just to make sure that everything is you understood everything. Yeah, so apparently all the tests here are running correctly. For 10, it should be a number. 60, 1000, 100,000. So these numbers go like so big, which is pretty interesting. Okay, I don't see any questions in the chat, so I guess we can go to the next one. Now, well, actually, let me think. Could we improve this anyway? Yeah, I don't have any idea now. I'm thinking about using recursion to find out the Fibonacci numbers, but yeah, that's probably not for this challenge. So yeah, let's move on to the next one. All right, largest prime factor. Okay, so the prime factor of 13,195 are 5, 7, 13, and 29. What is the largest prime factor of the given number? Okay, so let's see. Let's write again what we need to do. So we need the prime factors, so not only the factors, the prime ones. So we need to check, and we need to have a function is prime. Okay. So, well, let's see. This will check if a number is prime. Okay. All right, then we would probably loop again over the entire numbers as we did in the first challenge. So from 1 up to the number, but I knew that there is a trick, so we don't actually have to go up to the number, because I think there was either going up to the half of the number or the square root of the number. So I never really got this exactly, so we're going to test it. Because you can see here we have a huge number, and well, doing a loop over, let's see, 1,000 millions billions, that's, well, that's huge. Also, being the prime, we need to check all the numbers, so we need to check if it's divisible by only one and itself, so it doesn't have any divisors, I guess. Yeah, so for loop up to half. Let's go up to half of the number. Because, so if you're thinking about 20, right? So 10, which is half of it, it is a divisor, right? But 11, it's not anymore. And also 12 and 13, all the numbers from half up. But also 10, it's not a prime, because yeah, it has a divisor by 2, and 5. Okay, let's loop. So we need also just the largest. So we're going to keep track of the largest. So let largest first will be, I don't know, should start with 1. And now we're going to, let me remove this. So for let I equals, I think we can start with 2, or should 1 is definitely not the biggest, but oh well, let's start with 1. I less than or equal to half of the number divided by half, divided by 2, and I plus plus. Okay, now we need to check if is prime. So the I if is prime, and well, actually we can do I number modulus I equals 0, and it's a prime, right? So prime factors, Okie dokie. And I did this. We're going to create another function just to make it more readable. So is prime, and we're going to give it a number. And here, let's see, we want to start from 2, so let I equals 2, because 1 is divisible. So being a prime means it's only divisible by 1 and itself. So we want to loop over all the other numbers, or so from 2 up to the number, and if we find a divisor, then it's not a prime. Okay, I guess this also could go up to half. But let's do the brute force, and then if it fails, we can optimize it. So let I equals 2, I less than the number, I plus plus. Okay, and now if number divisible by I is 0, then we can already return false, right? So we get off the function and return false. Otherwise, we can return true, and this is a prime number. So let me put this here nicely a bit. Okay, so Quincy again, speaking highly of me, but I don't deserve it. Okay, so we're looping over the numbers, and now if this is the case, so if it's divisible and if it's a prime, then we want to store it in the largest. So largest should be I, right? Because that's the loop. Okay, and here we can return the largest. All right, this is my logic. Let's see if it's the good one. Okay, so something's wrong. Let's do some, yeah, look at that, test timed out. So this might be a problem for us. Okay, because it's a huge number. I said that we'll do 4 or 5, but maybe we'll get stuck at 3. All right. First, let's cancel that log to see what we get and why it's not working. Okay, so for this we get 29. That's good. For 2 we get 1. Okay, that's because we go up to half, and apparently that's not good. So let's see what happens for 3. I guess it's the same thing. We get only 1. For 5, yeah, so apparently that's not okay. Let's go up to the number prime factors. Yeah, feel free to correct me if you see the mistake. There might be a couple. All right, so this should work for a few, but then it will thank you, Quincy. Yeah, also feel free to support the freeCodeCamp channel by donating if you want. Super chat, it will help the organization. All right, now, yeah, this is what I was afraid of. We're passing these tests, but the big one is pretty big. I'm happy to see that you enjoyed it, Adam. Yeah, this is what I did with the freeCodeCamp curriculum, and also I'm going to do it again with the Python series after everything's working and all is good. So Andrew is saying that in is prime, only need to check if number is divisible by 2, 3, 5, and 7. All other numbers are divisible by 1. of these ends, if not a prime value. Yeah, but it could be a, for example, 13 is a prime. So I'm not sure if that will work. Yeah, so now it's failing because of its test timeout. So we need to reduce the number of loops we have, which will be pretty interesting. Yeah, so Kaja is saying, so if I mispronounce your name, sorry, is saying that instead of for loop running from from I equals to 1, can we run I equals to number divided by 2 till I is bigger than 1? So you're saying we should loop backwards. Yeah, that will be an idea. And then we save half of the loops. Yeah. I'm glad I did. Okay, but then we're going to have the same issue where we won't have 2 and 3 if we do I equals the half of the number, right? And we can also not change the largest. So let's comment this out. We need to do something and slowly figure it out. There probably must be some kind of I don't know, fancy thing to do it. But let's try this. So let I equals number divided by 2, I bigger than I guess 1. We can go there. I minus minus, so we go the other way around. And I guess we can check the same thing. Now the issue here will be, for example, for 2 we won't have 2, right? And also I, let's make it, if let's floor this number so we have a fixed number. So Florin, if a number is not a prime, it is bound to have a factor less than its square root, according to the common mathematical theorem. Yeah, so this is math-ish. Yeah, so I knew something about the square root. So you say that here we should go up to the square root of number, math square root, right? So this should save some loops. Also, if you check divisibility by 2 before the loop, you can start with I equals 3 and increment by 2 instead of incrementing by 1. That's another good suggestion, because we know that 4 is not a prime, right? So what you're saying here is that we can start with 3, we can increment by 2, so it will be 3, 5, 7, 9. And here, if the number is divisible by 2, then we can return false, right? So this is for the 2 case, or I don't know, for 2 case. Yeah, for case where, I don't know, divisible by 2. Yeah, I wanted to add a comment, never mind. All right, so this will save a lot of loops to check the prime. Let's see how this works for a number now. Yeah, so it still should return 2. And this is still timed out. Why did you have to do so big of a number? All right, so let's think. Well, this if divisible by 2, but if it's 2, we want to return true, right? It might be 2, the number itself might be 2, So then we should allow it. So we need to check if it's divisible by 2 and the number is different than 2, then we should return false, right? And now it should work for this test case, but we still have a lot of loops. Let's see what we could improve. I could try this now, but yeah, my only issue with this is that the largest, yeah, you can see that it's not working. I guess we could do seal, but still we don't get 2. All right, so this doesn't work now. We need to work on this one. Okay, now for the prime factors. Here also we shouldn't go up to the number. Let's think. We can also go to the square root, right? And we can also do what we did here. Skipping 2 at a time. So 1, 3, like that. 2. Well, let's try. Okay, now we get to 1. So we have these case scenarios where the largest prime factor, it's the number itself. Whoa, but look at this. So we kind of passed the test, the big one, which is pretty great. That means that we're not timed out anymore, which is pretty great. Now the only thing we need to figure out is what are we doing when the largest prime factor is the number itself. Let's think. So but why is, oh, well, I guess I think I know. So if the number itself is a prime, then that's the largest, right? So here we can just check if is prime. So if the number is prime, then we can just return the number, right? Because it's itself. And otherwise we need to do all this mambo jumbo. Fingers crossed. All right, look at that. We have 1% done of this Project Euler. Pretty nice. So yeah, see how we started with a brute force and we slowly adjusted the code to be faster and better and yeah. Okay. Yeah, also Marco is having a good point. Someone also suggested this, if we start from the back, and yeah, that will speed it up even faster, because yeah, the reason I didn't do from the back is that we had this case scenario when we needed to return the number. So I guess this is the case where the number itself is a prime. So then, in order to simplify this, well, to speed this up even more, we could do that. We could start by setting I to be square root of the number. We could go down to 1, and we could do I minus 2. So this way, whenever, well, I guess we could even not store the largest and just return I. So if we find something like this, return I, right? Because we're finding, so the first one that's divisible by the number, the I is divisible by the number, and if it's a prime, then it's the biggest prime, right? Okay, I think this speeds it up even more. Let's see. Okay, so something's not good. So square root, we go up to 1. Oh, I see where we might, so we might go, we might skip. The square root here might be something like an even number, right? So it might be something like 30. And then we're going to 28, 26, 24. So we're dropping like with 2, and they're all even numbers, so they're not primes, right? Then we need to see if this is even. So I guess I could just store. So yeah, this is, we'll already solve the problem and it works, but sometimes it's good to stretch it a little bit more to make it better, if you can, and well, if you have the time. I have the time, so let's stretch this even more. So we want to store the square root, right? And we want to see if it's an even number. And we'll start with that. Hello, Edmundo and Lawrence. Thank you on behalf of freeCodeCamp. Not sure, Quincy, if I can do that, but thank you on behalf of freeCodeCamp for supporting their organization. All right, so we start with this, and if the square root is an even number, then I guess let's add 1 to it. So square root plus equals 1, right? And now we can start with the square root here. And hopefully this will fix the bug we had. And it also speed this up even faster. Okay, so no. Wasn't this the problem? Let's see what we get. So if we do undefined. Okay, so we're probably getting here. It's not a number. Are we skipping it? Let's console.log all dies to see. Okay, so yeah, look at that. That's not good. We have decimals, so let's floor this. All right, and now do we get, look at that, we get 29. So yeah, should this work now? Awesome, perfect. I don't have time now, but if you do have time, use this solution and try to see what's the difference in the speed with the solution we had earlier. But I'd say this is much faster. Yeah, although the code is not the prettiest, but oh well. Okay, let me know if you have any questions for this one. Don't be shy in the chat. If you're in the chat, say hi, say say why, say whatever you want. It's a open communication. It's not don't let me feel alone. Yeah, all right, so I guess we can submit this and go to the fourth one. All right, ask me later, please. Okay, let's see. Palindrome. this is nice. So the largest palindrome product. A palindromic number reads the same both ways. So, for example, 112211 is the palindrome because you can read it the same backwards and forwards. Or 1001, or we have here 9009, so it's the same. Is the same thing. So let's see the chat. Okay. Yeah, I'm not sure, Quincy, if Marco meant about Project Euler to the back or just just the challenge itself. All right. The largest palindrome made from the product of two-digit number is 9009. So 91 times 99. Find the largest palindrome made from the product of two n-digit numbers. Okay. This is now quite interesting. So, yeah, there aren't a lot of test cases. First, we need to construct these numbers. So these three-digit numbers, two-digit numbers. And we can start the same way we did the previous challenge, so with the biggest number, and then slowly decrease. But there's a catch here. So what's the largest palindrome made from the product? Because, well, I'm thinking about having two loops, right? Starting with 99 and 99, and then we do 99 times 99, or 99 times 98, and so on and so forth. But then if we only dropping one loop, we might get to a palindrome, but then might not be the largest. Let's see. So for 99, we could do 99 times 99, then drop to, see, in this case, the correct answer is 99 times 91. So we could continue to drop one number, right? But something like this, 97, and then we eventually get to 99 times 91, which in this case works. But we might get down to 99 times, I don't know, for the three digits. We might get down to 999 times, I don't know, 101 for the three digits. Let me put three digits here. And this could be a palindrome, but it could not be the biggest, the largest, okay. Also, we need a function to determine is a palindrome. This is another thing we have to do. And yeah, I was thinking also to drop them by one, but then that also not, it's not the best. Or we could just do the brute force, see all the palindromes and then return the largest. Yeah, I think that should we start. Okay, so let's have an array palindromes like this, and now we're going to have two loops. So starting with I equals, so the n we're getting is the digit, and in order to have so if we get two, we want to start from 99. So let's see. 2. I could do something like, so the number could be array of n. This will create an array of length n, fill it up with 9s, and then join it. So yeah, let me show you what this black magic is. So we're creating an array of length n, and this array will be empty, and then we're filling it up with the number 9. So let me console log all the steps here so you can see. So array of n, then console.log array of n, fill with 9. See, we have an empty array, then we have an array of 999, and then well, we can console log this number, which is array fill join. You can see here we have 999, but what this doesn't show is that this is a string. So, well, we could say type of. So you can see it's a string, but we need a number. So in order to convert to a number, we could use parseInt like this, or what I usually do, it's add a plus in front. Where's the plus? Here. All right. Okay. Now we have a number, and this is the biggest number. So I guess I could say biggest, or nah, just leave it number. All right. Now let's go back to our loop. Well, not sure why I did if there. We need the for loop. So let I will be number, I greater than equals to 1, and I minus minus. Then for let j equals number. So we want two loops because we want to do the multiplication there. J greater than equals to 1, j minus minus. Okay. And now if I times j is a palindrome, so is palindrome, then we want to push it to the palindromes array. And we're pushing to the array, and then at the end we're going to get the biggest number. Palindromes.push. Well, let's store this. Const multiplication I times j. And here we can do multiplication, and here if it's a palindrome we can do that. All right, let's return the palindromes here just to have something returned, and let's create the isPalindrome function. So function is palindrome, and we get here a number. How do we check if this number is a palindrome? Okay, so I can see here potential infinite loop equals k I minus minus. I don't see why. That's interesting. Okay, yeah, that's what I want to do. Marco did it already. So we have a number, and we need to check, well, we need to reverse it and check with itself, right? And if they are equal, then that's a palindrome. So I want to return here the value of number to string, and I'll show you why we need the to string, equals to number to string again. So we're converting it to string because we can do now split. So we can get all the characters of the string and convert them into an array. We can reverse this array, reverse, oops, can type, and then we can join it back to a string. So now this is the reverse string of the number, and this is the number. All right, let's see. So to string, split in an array, we reverse the array, and then we join it back to a string. But it still says that it might be an infinite loop. Why? Can anyone see? Arrow function. Yeah, it's fine. We won't use arrow functions now, but well, I guess we could. So why is this? Well, now we have all the palindromes, right? But well, I guess I forgot to console.log this. So here we should get a bunch of palindromes. Look at that. So these are all the palindromes, which are quite a lot. And we need to get the maximum from this. We can do that easily by saying mat.max, and we destructure the array, so it will go inside the mat.max function. And it should work now. Yeah. I still don't know why it said that we have an infinite loop. Okay. What will happen if we say 4 here? Yeah. So it might run for a while. This is why probably. Yeah, that test timed out. It's interesting. So maybe if number is negative, then there is an infinite loop because it will never be positive again. Well, the number can be negative. Here we have 2 and 3. So from the test cases, we can't really have a negative number. And also, if it's a negative, then this condition will be false, right? And it will not loop. Yeah, so it shouldn't. If the number is less than 1, then this condition will be false, so it will run, well, it will get out of the loop. Yeah, so this works, although, yeah, I kind of don't understand why they say it's an infinite loop. Oh well, I guess it works. Let's see if we could improve this. So one way, now we're looping over all the numbers. So if we have 99, we're having 99 times 99 loops, which is a lot. And well, in this case, we only should loop like 8 times, 9 times to get to this value. How can we get to number to the largest number faster, so we don't have to loop over? Because this is not the best way now. We're just getting all the palindromes. Let's see. I don't quite have an idea now. There is something, there should be something, so we can stop sooner. Maybe save the number. Yeah, that will be actually good. We save, but it improves it a bit, because instead of having an array of, I don't know, 1,000 numbers, or which is not that big, we just have one number. But yeah, that makes sense. So const largest. I guess this needs to be minus infinity, so the lowest number possible. If it's palindrome and the multiplication is bigger than the largest, then here we can set the largest to be the multiplication, right? So now we don't do this, we just say largest, and we need to convert this to let because we can't reassign const. Okay, this should still work, and we save a bit of time. Yeah, that's right. I'm just looking here, so I don't want this kind of. Okay, yeah, I guess we should move on. And if you, yeah, by the way, I didn't say this in the beginning. I should have these challenges. You should try to do them on your own, and then well, this live stream will be uploaded, and probably this section of Project Euler will be uploaded separately, so you can watch it then, right? The loop doesn't need to continue if must is smaller than largest, perhaps. Yeah, it shouldn't, but so for example, in this case, we get to 91 times 99, right? So we only have like 10 loops, but we could get, so we might have a case where we have like 98 times something being the biggest. So then because of this number going lower, then jumping back up 99 multiplied by this number being being a smaller number, then the product of them will be bigger. So yeah, that's also not the perfect solution. All right, yeah, I guess let's leave it like this for now. I kind of have something in my mind somewhere. I think I saw this, but for some reason I can't remember now. So if you find this solution, please let me know. Well, the faster solution, and I'd be glad to take a look. I'm curious. I might search for it after the stream. All right, and let's see. Okay. Let's wrap it up now. We did 4. Let's go back. So we did 4 challenges, and we're going to, I'm not sure yet on which days I'm going to be live on freeCodeCamp. We still have to figure that out, but I'm going to be live every week, and we're going to continue this. Now, for those of you who are watching, and I highly recommend you taking part of this challenge. It's pretty fun. I recommend that you take a look at these problems and try to solve them on your own. And when I'm going live, join the live and, well, don't spoil the answer to me, but then you can see how I'm solving it, and, well, it will be much useful for you than just seeing me solve this, right? So yeah, I guess that's it. I hope you liked it. Let me know in the chat if you did, and if you want me to still to continue to do this. Thank you for freeCodeCamp for letting me do this on their channel. I don't know, it's more than I ever expected. I'm feeling very grateful for that. And yeah, let's help developers get better programming, find it. Well, my job is to make programming fun, and yeah. Thank you all for watching. Thank you, Lawrence, for your encouragement. Thank you all for joining, and I'll see you in the next live stream. Have a great day forward. Bye.